It says OCR's paper 2, the non-calculator paper from June 22. If we have a look at the grade boundaries, you need 36 marks for a 4 and 54 marks for a grade 5 on this paper. So question 1, we've just got some number work to do. We're going to start at 4 and take away 5. Imagine a number line if you need this. Starting at 4, 5 that way, you'll end up at -1. 2 times -3, well 2 3s are 6, so 2 times -3 is -6. Adding fractions, and we've already got common denominators. So we've got 1/7, we're adding another 2/7. Altogether, we've got 3/7. We don't suddenly change to 14ths here. A bit more challenging this one, we've got to do a half of 1.5. Well, we can take this bit by bit if you like. 1.5 is there. A half of that is a half. And a half of a half is a quarter. So we need to do a half added to a quarter, and that is 3/4. And then part B, we've got to find the largest prime factor of 30. Well, 30 as prime factors is 3 times 10. That's a prime number. Then we're going to do 10 is 2 times 5. Both prime numbers. That there is your largest prime factor. Question 2, we just want to know what fraction of this shape is shaded. There are 2 parts shaded out of 3 parts in total. Part B, what percentage is shaded? Well, we've got 3/4 shaded. If you want to turn this into a percentage, this is a non-calculator paper. Ideally, we want something out of 100. So 4 times something is 100. 4 times 25 is 100. So we'll do the same to the top. 3 times 25 is 75. 75 out of 100 is 75%. Some people just know that 3/4 is 75%. 0.2 is a fraction. If you're changing a decimal to a fraction, it will be out of 10, out of 100, or out of 1,000. And all we need to do is count how many digits after the decimal point. So there's only 1 digit after the decimal point. That means I want 1 0. So we're just going to write 2/10. 2/10 is the answer, but it says give your answer in its simplest form. So we'll half the top and half the bottom, and that comes out at 1/5. And part D of this question, what is 80% of 30? Well, 10%, we just divide this number by 10. 30 divided by 10 is 3. If we then want 80%, we're going to times this by 8. So I'm going to times this by 8, and 3 8s are 24. Question 3, bananas are 25p each, and we want to know how many we can get for £2. I'm just going to start counting up in 25s and see what I get. Let's start with 4 25s, 5, 10, 15, 20, and then 2, 4, 6, 8, 10. So 1, 2, 3, 4 bananas cost me £1. I think I'll get 8 bananas for £2. Question 4, we've got an 8-sided spinner, and the numbers 11 to 17 are written onto it. It says, what's the probability of landing on a number less than 12? So less than 12 means everything under 12. We're not going to include 12. There's only one number less than 12, so it will be 1 out of 8 numbers in total. It then says, find the probability of landing on a multiple of 3. Your multiples of 3 are your 3 times table. So 3, 6, 9, 12, 15, 18. And we're just going to find those here. There's 1, there's 1, and there's 1. They're your multiples of 3. There is only 3 of them out of 8 again. Question 5, we've got a ratio to simplify, so I'm just going to rewrite that in a bit of space. Usually simplifying a ratio is dividing both sides by the same thing, but if we've got a half, first thing we want to do is double everything, because that will have the effect of getting rid of this half. So 5 doubled is 10. 7.5 doubled, well 7 doubled is 14, and a half doubled is 1, and 14 add 1 is 15. Now we've got a ratio that we can start to divide. They're both in the 5 times table, so let's divide both sides by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. There's your answer, 2 to 3. This won't simplify any further. And in question 6, we've got a bar chart. Nice easy start for this. This is on Friday. There were 54 students absent. Complete the bar chart. So we just need to do a bar up to 54. Just double check your scale always. Is it going up in ones? 1, 2, 3, 4, 5? No. So try 2s, 2, 4, 6, 8, 10. Yeah, this is going up in 2s, so I want a bar up to 50, 2, 4, up to that little line there. So then I'm going to draw this. Be quite rough, you'd obviously use a ruler in your exam. That is 54 people on Friday. My pal Taylor says on Monday 150% of the students were absent. Could this be true? The answer to that is no, and the reason being 150% is more than everyone. 100% classes as everybody, so how can more than everyone be absent from school? Part C to this question is on the next page, and it says that there are 600 students, and we want to know the percentage of students that are absent on Thursday. So that's what I'm going to do here. So we know that there are 600 students altogether. We can have a look at Thursday and say, right, 42 students are absent on Thursday. So I'm just going to write that as a fraction first. 42 out of 600 are absent on Thursday. And I've just got a mark for writing this as a fraction. I now need to change this into a percentage, and it is an on-calculator paper. Remember, if I want a percentage, I need to be out of 100. So to go from 600 to 100, I'm dividing by 6. And that's what I'm going to do at the top here. I need to divide 42 by 6. So I'll do it over here. I'm going to say how many 6s go into 42. Well, 6 into 4 is no remainder 4. And 6 into 42 would be 7. So there are 7 6s in 42. So this here becomes 7 out of 100. Just divided top and bottom by 6. And 7 out of 100 is 7%. Question 7, we've got some brackets to multiply out or expand. Some people use a grid for this, some people use these little loops. As long as you remember you're multiplying, 5 times x is 5x, and 5 times positive 2 is positive 10. There's your answer. Part B says make R the subject, so that's what we want. We want R to be on its own. So what I need to do is manipulate this and basically get rid of everything else that's not R, and I do that by doing the opposites. Opposite of take 5 is add 5, and you end up with P add 5, just working downwards, equals 3R. Take 5 add 5 goes away. This is now saying 3R's, which is 3 times R, and the opposite of timesing is dividing. So I'm going to divide both sides by 3. On this side we get P plus 5, all divided by 3, and that equals times 3 divided by 3, gone away, R. We've finished. Question 8, some work with decimals to do. So first things first, we're going to do 3.08 added to 0.82. Just treat this as a normal column addition. Just make sure your decimal points are lined up. 8 add 2 is 10. 8 add the 1 is 9. And 3 add 0 is 3. You end up with 3.9 or 3.90. Part 2, we've got to do 7.7 divided by 11. I'm going to do that. I'm going to do 77 divided by 11 because that's easy. 77 divided by 11 is 7. Now the original question was 7.7. So I need a decimal point there. This starting number got 10 times smaller, meaning my answer is going to get 10 times smaller. So we end up with 0.7 rather than 7. And then part B, it's a BIDMAS question, but involving fractions and decimals. First thing I'm going to do is make everything the same. So we've got 3/5. I'm going to change that into a decimal just because everything else is in a decimal. 3/5 is 3 divided by 5, which is how many 5s go into 3. 5s into 3 is clearly 0, so we need some decimals and some digits to work with. 5s into 3 is 0 remainder 3, and 5s into 30 is 6. So what we're going to do is change this question. This now becomes 2.1, not take away 3/5, take away 0.6. And we're going to times that by 0.3. Remember BIDMAS, we do the brackets first. So I need to do 2.1, take away 0.6. You might just be able to work that out mentally, but I'll use a column method if not. Can't do 1 take 6, so let's borrow from there. 11 take 6 is 5, decimal, 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 and 1 take 0 is 1. So the answer to the brackets is 1.5, and we're going to times that by 0.3 now. Change colours. Rather than this, let's do 15 times 3. Let's make life easy. Get rid of the decimals. 15 times 3, 15, 30, 45. And now we just need to figure out where the decimal point goes in this answer. So if you look at my question, I've got a decimal point on one number, another decimal point, two numbers altogether after the decimal points, meaning two numbers altogether after the decimal point. The answer is 0.45. Question 9, we've got some money work to do, and we're instantly told that 50 child tickets are sold, and then we're given a ratio, children to adults, 5 to 2. So I'm just going to pick those key bits out. We'll rewrite that. Children is 5, adults is 2, that's just the ratio, but we also know that 50 child tickets are sold. So I've just pulled out all that information and written it underneath. Why have I done that? Well, straight away I can see my starting ratio gets multiplied by 10 to figure out the actual amount of tickets sold. So I'm going to do the same for the adults. If we times that by 10, that is now the number of adult tickets that were sold. We've now got the actual money work to do. So let's just focus on the child tickets. We've got 50 tickets and every one costs £2.50. This looks hard, but it's not really. If we do 2 times 50, that's 100. And 0.5 times 50 is just halving. And a half of 50 is 25. So that comes to 125. We'll do the same thing for the adults. Adults cost £5. So there's 20 adult tickets. They cost £5 each. All we've got to do is 5 lots of 20, which is 100. We can now do the total cost. We've got 125 for the child's tickets, £100 for the adults. Add these together, you get £225. Question 10, we've got a diagram. It's my mate Kai's garden, and it's in the shape of a right-angled triangle. And straight away it says, grass seed covers an area of 35 metres squared. Without even reading the rest of the question, I'm going to do the area of that triangle. Area of a triangle is base times height divided by 2. So we've got to do 20 times 15, then divided by 2. Well, 2 times 15 is 30. So 20 times 15 will be 300. And we're going to divide that by 2. And that comes to 150 square metres. If we focus on this bit of the question, it's talking about grass seed covering 35 metres squared. So I'm going to see how many 35s go into this. You can do it using bus stop, but I'm just going to add up 35s. 35 add 35 comes to 70. I'm going to add on another 35. That comes to 105. I'm going to add on another 35. That comes to 140. Let's keep going. 140 add 35 comes to 175. And that now covers the garden. So I just need to count how many bags I used, how many 35s. 1, 2, 3, 4, 5. I need 5 bags. I can't have 4 bags because that's not enough seed. We're now going to work on the next bit of the question, which says each bag of grass seeds costs £8.99, and we need the cost of buying the seeds. So I need 5 lots of £8.99, which looks quite difficult. So let's not do that. Let's do 5 lots of 9. Let's round this up to £9. 5 9s would be £45. But then I need to take away 5 pennies because I rounded every bag up by a penny. So I'm going to take away 5 pence. £45, take away 5 pence is £44.95. Question 11, we've got some pie chart work to do. We've got bus, train, walk, and then a space here for bike or car. So I need to really know how much angle I've got left for bike and car. So what I'm going to do is just add up the angles that's been used. We've got 160 for bus, 60 for train, and 20 for walking. If we add those together, 6, 12, 14, and then 1 add 1 is 2. We've used a 240 degrees of this pie chart, meaning over here, I can figure out what's left. The whole pie chart comes to 360. I'm going to take away 240, and that's going to be the angle that I've got left here. So note take note is note, 6 take 4 is 2, and 3 take 2 is 1. 120 degrees left for the people who biked or car. So let's write this ratio that we've been given. Bike to car is 2 to 3. And I know for these two things, there's 120 degrees. So I'm going to split 120 degrees into this ratio. So how many parts altogether? 2 add 3 is 5. I need to do 120 divided by 5. Let's do that over here. 5 into 1 is 0 remainder 1. 5 into 12 is 2 remainder 2. And 5 into 20 is 4. So the answer to this is 24 degrees. The bike part of this ratio takes up 2 of those. So I now need to do 2 times 24. Well, 2 20s are 40 and 2 4s are 8. That would be 48 degrees. And the car part of this ratio is 3 parts. So I need 3 lots of 24. Just going to add 24 onto this. 48 add 4 is 52. Add the 20, 72. So that's the angles that I need to draw. You would use a protractor to do this. Mine's going to be rough. I'm going to roughly guess what 48 degrees is. It'll kind of be about there. Please use a protractor for that. And then that should leave 72 degrees there. And you should really label this. So the 72 degrees is car and the 48 degrees is bike. Part B says, which way of travelling is the mode? And mode just means most frequent. Well, most people use the bus rather than anything else. Question 3, we've got some standard form work to do. It's talking about dinosaurs appearing on the earth and becoming extinct. Why are we using standard form? Simple reason. You're dealing with big numbers. Extremely long time ago, we're going to use standard form rather than write out all the zeros involved in that number. Part B says, how long were dinosaurs on the earth for? So what we need is the difference from when they appeared and when they became extinct. And I'm going to use the biggest number first. They appeared the longest time ago, 2.4 times 10 to the 8 years. And I'm going to subtract when they went extinct, which is 7 times 10 to the 7 years ago. Several ways to do this. I'm just going to go old school. I'm going to write this as a normal number. So we've got a 2 and a 4. And then I'm going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. Not 8 zeros. The first times 10 changes this to 24. Same with this. I'm now going to have 7 with 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Let's work this through. Note take note is no. And you're going to get the same all the way along here. 4 take 7 we can't do. So we're going to borrow and do 14 take 7. And then 1 is just 1. There is your answer, but it does say give your answer in standard form. So I've got a 1 and a 7. I'm going to write 1.7. Remembering this first number has to be between 1 and 10. And in standard form, we've got 1.7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 1.7 times 10 to the 8. Powers work to do. We're looking to hit 784 by multiplying something by 49. 7 squared is 49. Well, it's not 2 to the 1, because 2 to the 1 times 49 is 49. 2 squared is 4. 4 49s won't come near this. 2 cubed, 2, 4, 8. 8 49s, we'll think about 8 50s. That would only be about 400. I think it has to be 2 to the power of 4. 2 to the power of 4 is 16. And if we think about 16 times 49, well, let's just look at 16 times 50. A half of 16 is 8. So 16 times 50 would be 800. Which is very close to 784. So I'm pretty confident that that is a 4 there. Part B says use this answer to find the square root of 784. So we're looking for something squared to be 784. So we can work out the square root of 784. Well, we know that 2 to the power of 4 times 7 squared is 784. If I just rewrite 2 to the power of 4 as 2 squared times 7 squared. And what that is 4 squared times 7 squared. And 4 squared times 7 squared is the same as 4 times 7 all squared, and that's 28 squared. 28 squared will be 784. Question 14, we've got a transformation question, and there's two separate transformations that move A onto B. The first one's quite nice. If we pick a corner and the corner we're aiming for, we can see that that's gone 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4 down. So that is called a translation. When we've just moved left and right, we can say translation, and then we're going to use a vector. 5 to the right, we just put a 5 on the top, and 4 down, we have to put a negative 4. This top number is left and right. This bottom number is up and down. Positive numbers go right, positive numbers go up. That's why I've written negative 4 there. The second transformation is a bit more tricky. I think we can get there if we spin this shape around. Imagine it spins a full half a turn. So I'm going to write that down. I'm going to write rotation, and I'm going to say it's 180 degrees. If you flip that shape a full half turn, it will look like this one. So we've got marks there. We just need to figure out where it's spun around. Now what we can do is match up points again. If I match this point to this point and draw a line, and then match this point to this point and draw myself a little line, where those lines cross over should be the center of rotation, should be where we've spun around. So I need to write that down as well. We call it the center of rotation, and that is 0, -2. There's plenty of marks for just saying. Question 15, we've got y being inversely proportional to x, and if that's true, then there's a special rule. Y multiplied by x always comes to the same number. It's called a constant. If you've got inverse proportion, whenever you times those two numbers together, they always come to the same answer. So let's figure out what that answer is. Y is 20, x is 3, and 20 times 3 is 60. Again, if y is inversely proportional to x, whatever numbers you choose for y and x, they will always times to make 60, the same number. It says find the value of y when x is 12. So we need to say that something times by 12 comes to 60, that same number. Something times 12 is 60, that's something, x must be 5. 5 times 12 is 60. Question 16, we've got a bearings diagram with algebra, so this is a bit gross. It says the bearing of the bell tower from the fountain. So what we're looking at here is there's the fountain, that's towards the bell tower, and the bearing of the bell tower from the fountain will be that one. And it says it's 140 degrees more than the bearing of the statue from the fountain. So this here is 140 degrees more than this x. So as an algebraic expression, we're going to write that as x plus 140. It's just this total bearing altogether. Part B says the bearing of the bell tower from the fountain, so same thing but everything again, is also 3 times the bearing of the statue from the fountain. 3 times this. Can we write a different expression from that? Well, if all of this is 3 times this, then all of this red thing is also just 3x. And what I'm going to do is I'm going to combine parts A and B here. I know all of this bearing is 3x. That comes from this bit of the question. I also know that all of this bearing that I did in blue to start with was x plus 140. And these are the same bearing, so they're equal to each other. What we've done is create an equation that we can now go on and solve. It's got x's on both sides, so let's get rid of the smallest x's. 3x take x is 2x. X take x is gone, and we're left with 140. If we now divide both sides by 2, you get x equals 70. 140 divided by 2 is 70. What are we actually working out? Work out the bearing of the bell tower from the fountain. So the bell tower from the fountain, remember, is everything. And we've just said that that was 3x. You could also use this one if you want. I'm just going to use 3x. 3x is 3 times 70. Well, 3 sevens are 21. So that would be 210 degrees. We've got some information about scoring points. and someone plays this game 100 times. And what we've got is the relative frequencies of their scores. So the first thing we need to know is all these relative frequencies always add up to 1. So I'm just going to see what I've got to start with. I've got 0.08 added to 0.42 added to 0.38, and what that comes to, that's 18, 3, 4, that's 8, and we've got 0.88. So this box here is going to be 1, take away 0.88, and that is 0.12. My friend Morgan says I scored more than 160 points in the 100 turns. So what we've got in the table is basically how many times out of 100 they got 1 point. How many times out of 100 they got 2 points. If I take this 0.42 and multiply it by 100, what we get is simply 42. So they got 1 point 42 times. So I'm going to multiply that by 1. If we look at how many times they got 2 points, well, I'll just do 0.38 times 100, and that's going to tell me how many times they got 2 points. So that's how many times they got 2 points. For total points, I'll multiply by 2, and 2 times 38 is 76. And then I don't really need to, but I can look at this final part. They got 3 points a certain amount of times, and how many times was that? Well, 0.12 multiplied by the 100 times that they played. 12 times they hit 3 points, so 12 lots of 3 is 36. And if I total these, I'll get their total amounts of points. 42 add 76 is 118. This would be 148. Add on the 6 is 154 points. It says, is Morgan correct? Make sure you say, no, Morgan is not correct. We've got quite a tricky probability question. We've got red, blue, and yellow marbles in a bag. Now, what we don't know is how many marbles in this bag. So I'm going to skip over this first bit because that's talking about the red marbles. What we'll just look at first is the yellow marbles. So we know that the probability of yellow is 9 out of something. We do not know how many marbles in the bag. We know blue marbles, the probability is 3 times as much as the yellow marbles. So blue marbles, well, 3 9s are 27, and that's also out of the same something, the same total. We do know that red probability is 2/5, but that's not saying there are 5 marbles in the bag, because that's the simplified probability. They could be 4 out of 10 or 8 out of 20. So we don't know this total. What we do know is if we add those 3 fractions together, then that's going to give us everything. That's the whole one. So we can kind of start to work this through at this point in time. So what I'm going to do is just add this fraction together on the left. 9 somethings add 27 somethings is 36 somethings. We've already got common denominators there, if you like. Added to 2/5 comes to the whole one. What I'm going to do now is just start to solve this. If I know this add 2/5 come to 1, then this here, 36 somethings, will just be 1 take away 2/5. And 1 take away 2/5 is 3/5. So all I've got to do now is convert this fraction of 3/5 into 36 somethings. So I'll just rewrite it. 3/5 equals 36 somethings. Well, if I multiply that by 12, I get 36. So I'm going to multiply that by 12, and 5 times 12 is 60. Question 19, we've got some trigonometry to do, and this is non-calculator trigonometry. First part is just setting us up. It says, what's the value of sine 30? If you're on the non-calculator paper, it'll often be a half what you're using. So sine 30 is a half. We've then got a right angle triangle where we're trying to find this side. It's definitely trigonometry. That there is the opposite. The longest side is the hypotenuse. So I'm going to write so, ka, toa, and figure out which of these is opposite and hypotenuse. This is a sine question, and your big hint is in part A of this. So we're going to write sine theta, remember that's your angle, equals opposite over hypotenuse. Then we're going to start substituting in. Theta is 30, sine 30 equals, the opposite is the thing we're looking for, and the hypotenuse is 24. If we want to find the value of x, we need to multiply both sides by 24 to get rid of this divide by 24, and we end up with 24 times the sine of 30 equals x. Part A of this question guided us towards sine of 30 being a half, so we're going to say this becomes 24 times a half equals x. Again, non-calculator, but this is easier than it looks. This is just saying what is a half of 24. 12 is a half of 24. And there's your answer, 12. Question 20, quite a tricky straight line graph question, but it is towards the back end of this paper. So we've got some coordinates for A, B, C. The one we don't have is D. So I'm going to figure that out now. I need to know how far across I am. Well, I know that this side length here, from 3 to 9, is 6. So because this is a parallelogram, this will always also be 6 across. So this coordinate comes across 6 and down 6. Can you see I'm lining up with that as well? So D is the point across 6 and down 6, just using how long the side is, and then down to minus 6. We're actually looking for the equation of this line. So if I can get 2 points on this line, I can work that out. Well, this point here is 9 across, but none up and down. So they're my 2 coordinates. The minute you've got 2 coordinates, you can start to work out the gradient of your straight line. And your gradient just comes from these y values subtracted from each other. So I'm going to do 0 take negative 6. 0 take negative 6. And I need to divide that by these x values subtracted from each other. So I did 0 take negative 6. I'm going to do 9 take 6. And what we get, 0 take negative 6 is positive 6. And 9 take 6 is 3. And 6 divided by 3 is 2. The gradient of this straight line is 2. What we've also got is an x and a y. I could have used those two, but these look nicer. So let's just write down everything we've got. We know that x equals 9. Y equals 0, just picking these 2 coordinates. We know my gradient m is 2. All of this can be substituted into the general equation of a straight line, y equals mx plus c. So I'm going to put all of this into that equation, and c is the thing that we don't know. Y is 0, so 0 equals m is 2, x is 9, and this becomes 2 times 9. mx is a multiplication, plus c. 0 equals 2 9s are 18, plus c. 18 add something makes 0. The only way that works is if c is minus 18. 18 add minus 18 is 0. We've now got the missing piece to this puzzle. So what I'm going to do is circle my gradient, circle c, and we go right back to y equals mx plus c. The y and the x stay as they are now. M is 2, and c is minus 18. There's the equation of the straight line. Question 21, a bit of an annoying one to start with. We've got 2 people saying that this is an equation or an identity. This is actually an identity. Okay, so I'm just going to write that down. And the reason it's not an equation, when you expand these brackets, you always get this. There's no other answer to these brackets expanded. So I'm just going to write that down as well. It's a bit of a weird one to try and explain, but this will always come to this. Very much like this. If I write x plus y equals y plus x, that's also an identity. And what I'm saying is that any numbers, this always works for. For example, 1 plus 2 is always the same as 2 plus 1. That's an identity right there, saying it's always correct. And that's true for this expanded bracket. Part B says solve by factorising. So factorising, we're looking for double brackets. There's going to be an x in each bracket. And we're looking for 2 numbers that add to 4, but times to minus 12. 2 numbers that times to minus 12, but add to 4, positive 6 and negative 2. 6 add minus 2 is 4. 6 times minus 2 is minus 12. Remember, when you're solving, you need to reverse these. So x becomes minus 6 and x becomes positive 2. A diagram of a sandpit, and we've got something that's already been drawn. This zone here is all the points 80 centimetres from this corner. So if we actually go down to the question, it's saying you get 1 point if the ball lands within 80 centimetres of the corner. So if you land this ball anywhere in that zone, you get 1 point. We need to work on these next constructions. It says you also get 1 point if the ball is closer to AB than AD. So closer to this line than to this line. And what that's telling you to do is cut this angle in half. So we're going to need a compass to do that. I'm going to use this arc that's already drawn. You're going to put your compass point here and draw an arc around it. You're then going to move your compass point to here without changing the compass and draw an arc around that. And if we connect that crossover zone there, we've cut the angle in half. I'm sorry, that's a bit rough doing it on a device. And it says you get 1 point if the ball is closer to AB than AD. So all of this zone will be 1 point. If you're in this part here, you now get 2 points because you're closer to AB than AD, but also within this first arc. So I'll just jot that in as well. You also get 1 point if the ball is closer to A than B. So there's A, there's B. Closer to A than B means cut that line in half. And again, use a compass for that. So compass point on A and draw an arc. Compass point on B without changing it and draw an arc. And if you connect those two crosses, you'll have cut the line in half. So mine's very rough and I do apologise, but hopefully you understand the idea. And it says closer to A than B also gets a point. So on this side of the line gets a point. Now, I'm not interested in that zone because actually the question says 2 points. So where do we get 2 points? Well, this part here now has just moved to 3 points. Because that covers everything. Okay, closer to the point A, closer to this bottom line, and within the section. So that bit there is 3 points. That's no good. This bit up here is actually 2 points. Because I'm within that first arc and I'm on the left-hand side of that line. I'm closer to A than B. So that's 2 points. There's somewhere else which is 2 points, which is down here. Okay, I'm closer to AB and I'm on the left of the green line. So I'll shade it in so hopefully you can see it. That there is also 2 points, the same as that one. You're looking for all the zones where 2 of these 3 things are met. And it's in those 2 green parts there.